In this tutorial, we will use the preprocessor to import well deviation survey files and overlay these files over the simulation grid to find out where the well survey files intersect with the grid. This will help us to get the well locations for the wells and also to get the perforation fraction of those well locations. So in this case, let's open up an example file that we have used for this purpose. It is a file at this point in time we have some grid cell parameters, and I will open up, say, the top depth parameter and trying to fit it in the screen here. And this top depth parameter has the certain values, and you want to see that there are no wells at all currently. We can apply the operation with or without wells, but just for a clean start, I shall use this status without wells. So under the wells menu item, you can show the well location form, and in the well location form, there's an option here to get locations from well survey file. If I use the option, and it comes up with a form like this. Now, the well survey file has a certain format that we have to follow in Exodus. So if I go File, create a new survey file, the extension is VY. That file has a name to it, the file name itself, the well name, offsets, service coordinates, X and Y, unit system, reference depth for calibrating or casing floor, completion intervals. There's a certain format, date, in exactly this format, date from to, and values for the measured depth, true vertical depth, northing, eastings. I will open up, once you put the information in from Excel, for example, you can copy and paste from Excel. Once you put that information in, you can save the file. In this case, I'm not creating one, but I'm going to open up a file that I've already created. In this form here, I'm going to obtain well locations from 2 well survey files, and this would be, in this case here, I've chosen a 6 of 29 well and a 7 of 29. Let me do one at a time. 6 of 29, and the other one is going to be 7 of 21. These 2 wells have well survey files. I can display and edit the well survey file itself. So in this case here, in this particular example, this survey file for this well has this information for the coordinates, the measured depth, and if there was a date or for completions, we will put it, say, year 2000, say 01, 05, year, month, date, and from to interval. So the from to interval maybe from 1800 to 2089, for example. 1800 from to a dash 28, 29, and if there's another date, you can put in date again, following on this line, and save the information. So we can form close, and it says dollar was changed. You want to save it, say yes, save it, and use the new name or a different name. I can use the same name here, replace it, yes. So this information can be edited, modified for different wells. So this is the second well. So that, yes. So let me try to infill these 2 wells. If I got 10 wells, I can have, or 20 wells, I can put them all in and save that as a list of wells that I have infilled. So let's do OK to find well locations, and it's going to find with certain parameters. A search radius of 5 cells. If you find that this model is not finding the well locations correctly, you can try to expand the search radius and look at some other options down here. So let's say OK to find intersections, and files don't have perf will be defaulted to open hole. So this will be defaulted to open hole. So OK to that, and it finds the well locations for the wells. And it's got the IJK location. It's put in the time of the perforation, 2000. And it's put in perforation fraction based on the length of the well inside the grid cell in the corresponding direction of that well. So it's found that if you look at the grid cell data, you can see the grid cell data now has well locations. If I show the well names, highlight wells, we will see the well names, turn the well numbers on. Okay, we will see the well numbers, well names on. Now we can also look at in a 3D manner, display 3D, and open the 3D, and we come up with a form that says, do you want to show the model cell range? Sure, I'm going to use the entire model and show all cells and process. Okay, the process, and then it comes up with a 3D picture. The 3D picture of the two wells, and if I were to choose the option to make the cells partially opaque, transparent, I mean, so partially transparency point, opacity of 0.1, for example, you can see that the internal structure, we can see where the locations of the path of the well inside this model. And if you want to show the actual survey file itself to see how does it compare, to see if the well actually is in formation or out of formation, you can click on that option to show well survey files, browse and add, and pick up the same two survey files that we have used for the infill, and click and display the well survey files, and then we can see that the actual survey file trajectory is fairly close to the calculated perforations. If I were to go in here and zoom in on this display, zoom on this particular area, go back, you can see that the zoom has worked here, and we can see that the well locations are very close to the actual path of the well. Because the well locations are at the middle of the cell, the X, Y, Z is not necessarily at the middle of the cell. We can go and look at different layers, layer 1, and so on. So we can use the 3D picture to see the actual path of the survey file to see whether it's in or out of formation. And we can use the infill, the get well locations from the survey file to compute for us the actual locations of the well. Thank you for your attention.